Hey, welcome to the video. Today we're gonna go through differentiation. We're gonna go through the rules of different functions and how to apply those rules. Basically, for differentiation, all you need to know are the rules. These rules might be given to you with your exam paper, or you might need to bring your own formula sheet. So if you're told to bring your own formula sheet, try to put in as much differentiation rules as possible. Also, as you practice these rules, you'll familiarize yourself with them, and you might not even have to refer back to them because they'll be in your head as you do as much practice as possible. So a good thing with maths in general is to do as many problems as you can just to familiarize yourself with the rules. So let's get into the first rule. One of the easiest is the derivative of a constant function. Simply means if you have a function, here you're asked to get the derivative of x. So if you have a function that does not contain x, it can be seen as a constant, and therefore the derivative of x of a constant function is 0. Let's get into some examples to show you. So this is I put all the rules in a square like that so you can refer back to it. So first example we have here is the ddx of 2. ddx of 2 will be 0 because our constant is 2. ddx of 12, also 0 because our constant is 12. ddx of y squared is 0 because y squared here is not a function of x. This is a function of y. So it's seen as a constant. Let's move on to the next rule. That's the power rule. It states that ddx of x to the power n equals n times x to the power n minus 1. Familiarize yourself with this one. The more practice you do. It's one easy one, no need to worry about it. So it states here ddx of x to the n is just n times x to the n minus 1, which means that ddx x cubed is equal to 3x 3 minus 1 because our n is 3 in this case, as you can see. So it's equal to 3 times x 3 minus 1, and that gives us 3x cubed. Alright, ddx of 12, follow the same procedure. It's 12x 12 minus 1, which is 12x to the power 11. Right? ddx of x, this can also be seen as ddx of x to the 1, because x, any number to the exponent 1 is just equal to the same number. So here we have n as 1, so it's equivalent to 1 times x 1 minus 1, which is equivalent to 1 times 1, or x to the power 0, which is still 1. Therefore our answer is just 1 times 1 in this case. Let's move on to the next rule. The next rule is the constant multiple rule, and it states that ddx of x, ddx of c fx, which is the function we're getting the derivative, is equal to c times ddx of fx. Our c here is a constant, so what it's really stating is that you can remove the constant out of the function, because, well, you can take away the constant from the function, get the derivative of the function, then multiply the constant back with the function to get the answer, because the constant here does not affect the function. Unless the constant was part of the function, that's another story. But in this case, the function is just a multiple of the constant. So you can remove the constant, then multiply it back later. Let me show you some examples of that. Here we have ddx of 12, x to the power 12. Now 12 is our constant here, so we can put that aside for now. Get the derivative of x to the power 12, which is our function. That will be 12 times 12x, 12 minus 1 as we learned previously, which is 12 times 12x to the power 11. Simply multiplying 12 times 12 is 144, x to the power 11. Let's do a much more simpler one. Probably should have started with that. 2, the derivative of 2x cubed. Our constant here is 2. You can put that out. Get the derivative of x cubed. That multiplies together, and that will be 2 times 3x squared. And squared comes from 3 minus 1. Remember that. Which then equals 6x cubed. That's our final answer. Let's move on to the next rule. The next rule we're going to go through is the sum rule. Now the sum rule states that if you are asked to find the derivative of fx plus gx, which is two functions added together, then you can separate them, get the derivative of fx, get the derivative of gx, and add them. So ddx of fx plus gx equals ddx of fx plus ddx of gx. Let's get into an example. Sorry about that. Let me just put this here. Alright, our example says find ddx of 2x plus 12, which is our fx in this case, and plus x to the power 12, which is our gx in this case. So that can simply equate to, according to the sum rule, the derivative of x plus the derivative of the derivative of f plus the derivative of g. I'd like to state that the notation for derivatives, you can either write f prime x, and this represents ddx of fx. So f prime x, some textbooks might write it like this. It simply means ddx of fx, or f prime gx simply means ddx of gx. It's just notation. So the derivative of f simply here is 4x. Remember from our constant multiple rule that if we remove 2 out, get the derivative of x squared, which is 2 times x. We end up with 2 times x, which is 4x. So 4x is a constant. I feel like I should do this in full instead of skipping steps. The more you familiarize yourself with derivatives, easier it becomes, and you might skip a few steps just to get to the answer. So let me do it the long way so you don't get confused. F prime x is 2 constant multiple rule, and then 2x, which is the first rule we learned. That's the second rule we learned, that's the power rule. 2x, 2 minus 1, and then I'll put this in brackets, and 0 for constant, and we add 12. This is gx now that we're getting, so 12x to the 12 minus 1. So our final answer then equals to 4x 1 plus 0 plus 12x to the power 11, which is simply now 4x plus 12x to the power 11. Final answer. Hope you get that. Let's move to the next rule. The next rule, hope you can see this, is the difference rule. Almost the same as the sum rule, just now we're subtracting functions instead of adding functions. So ddx of fx minus gx equals ddx of fx minus ddx of gx. Let's just jump into the example. It'll make sense, I'm pretty sure it makes sense. So here I said let fx equal 2x plus 12 and gx equals 2. X to the x squared, sorry. And we're asked to find ddx of fx minus gx. So let's fill it in. Let's put in fx and gx, see what we have. ddx, sorry about that, battery died. ddx of 2x plus 2x plus 12 minus x squared equals ddx 2x plus 12 2x squared plus 12 minus ddx of x squared. This we've calculated before, is equal to 4x plus 0. No need to add the 0, it's negligible. Minus derivative of x squared is simply 2x. So the final answer is 2x. Let's move on to the next rule. Next rule we're gonna go through is the derivative of a natural exponential function. This one's very simple. Simply ddx of ex equals ex. Let's get into an example. We have here told to find 2e to the x. As you can see, there's a constant before it. Apply constant multiple rules is 2 times the derivative of e to the x. As the rule states, the derivative of e to the x is simply e to the x, so our final answer here is the same as 2e to the x. Here we have two, you can see them as two functions. Let's just work through it and see how it works out. We have dx 2e to the x. We can separate them using the sum rule. ddx 12. We're left with 2ex as we calculated here, and 0 because 12 is a constant. And guess what? We have the same answer. That's the derivative of 2ex plus 12. Next rule, we're going to go through our derivative of trig functions. It states that ddx of sin x equals cos x, ddx of cos x minus sin x, ddx of cos x equals minus sin x, ddx of tan x equals sec squared x, ddx of cos x x equals minus cos x cot x, ddx of sec x equals sec x tan x, ddx of cot x equals minus cos x squared x. Let's get into, we're going to do two examples here, not all of them. Thing about trig functions in general is if you know the rules, you can apply them. Well, that's basically the rules. The system of getting derivatives in general. If you know the rules and you substitute the variables properly, you can find basically every answer. So here the example gonna go through is ddx of 2 sin x plus 12. You can separate these two using the sum rule. We got 2 sin x plus ddx. I didn't leave enough space here. I hope you can see it though and follow it. ddx of 12. Let me separate this like that. You can vector out the constant. We have we have 2 times ddx of sin x plus ddx of 12. We know 0 because 12 is a constant in this case. And then we have 2 here, and we need to find the derivative of sin x, which is just cos x. So our final answer is 2 cos x. Here, another example we have is 2 ddx. Find ddx of 2 cos x. So 2, again, being the constant multiple, you can apply the constant multiple rule. We're left with the derivative of 2 cos x to find. So cos x is minus cosec x. The derivative of cosec x is minus cosec x cot x. So our final answer is minus 2 cosec x cotangent x. Let's get into another example. I know I'm messing up my words, but I hope you can follow what I'm going through. Let's go to another rule. Let's see if we did. Trig functions. Let's get into the chain rule. Chain rule sort of tries to simplify more complicated rules. So if you have a function within a function, if you have like, say, the square root of x squared plus 1. X squared plus 1 can be your inner function, and the square root of that inner function can be your total function. You get fx can be the square root of the inner function, and x squared plus 1 can be the inner function. If that makes sense. I hope that makes sense. So if you have something like that, like you have an outer function, you have an inner function, you have an inner function within an outer function, then it states that the derivative of the entire thing equals the derivative of the outer function multiplied by the derivative of the inner function. So let's get into an example. I hope it makes more sense. So here we're asked to find, here I should put a cube there. Yeah. We're asked to find x to the power 12 plus 1 all cubed. Find the derivative. I don't know what I was thinking when I wrote this. But our fx is this, and we're asked to find the derivative of fx. So back to the rule, it states that our inner function, our outer function, multiplied by the derivative of our inner function. So our outer function here, in this case, let's call it f of u. It will be equal to u cubed. So in this case, u is equal to x squared plus 1. So let's get the derivative of f of u. That will simply equals 3 u squared, right? And the derivative of u will simply equal to 2x. So now I can substitute in, multiply throughout. We have 3 u squared as our outer function, multiplied by the derivative of the inner function, which is 2x. And we know that u equals x squared plus 1. So we can substitute for u. We have x squared plus 1 times 2x. So all out we have 3x squared plus 3 multiplied by 2x. Final answer is 6x cubed plus 6x. Alright, let's move on to another rule. So this is the rule of if you have an exponent as x. So ddx of a to the power x is simply equal to a to the x times ln of that base value. I'm not going to get into an example because I feel like it's simply a matter of substitution, as you've seen with the other questions, the other rules that we have practiced. It's just simply substitution. As long as you know the rule, you can apply them. So I'm also going to just show you the rules that are left over. We also have inverse trig functions. ddx of sine inverse x equals 1 over the root 1 minus x squared. ddx of cos inverse x equals 1 minus 1 over the root 1 minus x squared. ddx of tan inverse x equals 1 over 1 plus x squared. ddx of cos x equals minus 1 over x times root x squared minus 1. ddx of sec inverse x equals 1 over x times root x squared minus 1 ddx of cot inverse x equals minus 1 over 1 plus x squared. Also with logarithmic functions, if you're asked to find the derivative of a log function, it's just 1 over x ln times the base, ln of the base. And the derivative of a ln function is just 1 over x, because ln, remember, is a function of e. So the base is e doesn't change, so it's going to be 1 over x. So let's get into one of the other rules too, actually. 2 rules left of what I think is necessary to help you with more complicated questions. Let's get into the product rule. It states that ddx of fx times gx equals f times the derivative of g plus g times the derivative of f. Let's get into an example. I have this one here. So here we're asked to find the derivative of 2x cubed plus 1 times x squared plus x squared minus 1. So let's see, I hope you can see the rule up here. I hope you can see the question too. I think I'll just write it down here. So it states UNIX ddx of fx gx is equal to f g prime plus g prime. Hope I got that right. Yeah. In our case, this is our fx, this is our gx. So the derivative, okay, it says the rule states that you multiply f, which is 2x cubed plus 1 times the derivative of g. Derivative of g in this case will be 2x minus 0, so I'll leave that out, and you add g, which is x squared minus 1, and you've multiplied by the derivative of fx, which is 6x squared plus 0. So that's our final answer. Then you can just multiply out to get the answer, which is now 4x to the 4 plus 2x plus 6x to the 4 minus 6x squared. That should give us, let's see, 10x4 minus 6x squared plus 2x. Hope that makes sense. Let's move on to the quotient rule. Unlike the product rule, the quotient rule is a way to approach a derivative that's a function of a function. So usually if you have a division, a fraction type question, and you're asked to find the derivative of something, like function of a function, the answer will be gx times the derivative of fx minus fx times the derivative of gx over g squared. Here's an example to demonstrate it. Let me write down the equation for you. dx of fx over gx is equal to gx derivative of fx minus fx times the derivative of gx over gx squared. Cool. So yeah, let's break it down into fx and gx. What is our fx in this case, in this question? Our fx is 2x plus 1. Our gx, hope you can still see this, our gx is ex. So our derivative of fx equals 2, and our derivative of ex equals e to x. So if we had to apply this to get to the answer, we have g, which is e to the x, times derivative of f, which is 2, minus f, which is 2x plus 1, times the derivative of g, which is e to the x, divided by g squared, g e to the x squared. So our final answer, let's leave this out. Final answer is 2ex, multiply out 2xex minus ex all over e squared x. And our final answer, we can subtract ex, can subtract these two like terms, and we have ex minus 2x ex all over e squared x. I guess we can get rid of ex too. Yeah, we could also divide by 1 over ex and 1 over ex there, multiply, and we have 1 minus 2x over ex as our final answer. So let's get into a problem I saw. See if you can figure this out. We're asked to find the derivative of gx, gx in this case being root x minus 1 over x to the power 4 plus 1, and that we can apply the, what's that rule called? We can apply the chain rule, yes, which states that we have an outer function. Let's see, how am I gonna put this? We have an outer function, let's call it hx, and we have an inner function g, let's use another term, fx. Now our inner function here is x minus 1 over x 4 plus 1. Our other function here, let's use a variable u instead. Let's use a different variable. hu equals root u. So our fx here can be equal to u. With the chain rule, it stated that if you have a function within a function, you take the outer function's derivative. So the outer function in our case was hu. So the derivative of hu multiplied by the derivative of the inner function, which is just, let's say it's u prime. So derivative of sorry for tilting this, derivative of hu equals half, because remember that the root of u is equal to u to the power half. So it's half minus u minus 1 over 2, plus 1 over 2 minus 1, which is equal to half u minus half, right? You can also write it like this: 1 over 2 half, which is the same as 1 over 2 root u. So any of these three represent the same thing, and you can use it in the function. So it states that you get the derivative of h, which we got there, and you get the derivative of u. So what's the derivative of u in this case? Here we have a quotient, a function over a function, so we can apply the quotient rule. The quotient rule stated that you take the bottom function, x4 plus 1, you multiply by the derivative of the top, which is 1, minus the top function, which is x minus 1, multiplied by the derivative of the bottom function, which is 4x, and then divide all of this by the bottom function, x4 plus 1 squared. So we have x4 plus 1 minus 4x plus, is 4x squared. 4x squared plus 4x over, I'll leave this as is, 4x plus 1 squared. Anything we can make a bit smaller? Does not look like it, so we'll just substitute this into the equation. So we have 1 over, for hu we have 1 over 2 root u. For u prime we have x4, I'm just gonna put it in order and say minus 4x squared plus 4x plus 1. Sorry that this is looking very complicated, I just didn't make enough space for it in order to explain the rules. Over x4 plus 1 squared. And if we multiply throughout, we have x4 minus 4x squared plus 4x plus 1 all over 2 root u x4 plus 1 squared. And remember that u wasn't part of the equation in the first place, so u is equal to this. It's looking very hairy, but this is our final answer. So x4 minus 4x squared plus 4x plus 1, 2 times root, that's all u, x minus 1 over x4 plus 1 multiplied by x to the 4 plus 1 squared. And that's our final answer. It's crazy, I know, but you should get right marks for that. And that's derivatives in general. If you know the rules, you can apply the rules and find any answer they ask you. It's not that difficult if you can break it down to how to apply each individual rule. Like here, we use chain rule, we use quotient rule, a bit of substitution was involved. Complicated, but you'll get all the marks you need. And yeah, that's differentiation. I hope this helped.